We're here at the Data Warehouse and BI Summit in Amsterdam, and with me is Mark Madsen. Welcome, Mark.
Thank you.
Your first session is on multi-use data infrastructures. Can you tell me what you mean with that?
Sure. So what I mean when I say something like multi-use infrastructure is just data infrastructure that's usable not just for BI, but for a bunch of other things. So I have to deal with real-time analytics, and we've got machine learning projects, and all these different problems. And what we've been doing for a long time now is building one system after another to solve each problem independently, but they all use the same data. It's just structured differently or uses a different engine, and we need to be able to build systems that support that.
And while you're building such a multi-use data infrastructure or architecture, one of the challenges, I suppose, is how do we keep it future-proof? So technology is changing very rapidly, at least in the days of big data. If you see the technology stack, well, you just can't keep up with it. So how do we build a future-proof architecture, or is that even possible?
I don't think it's possible because your assumption is that architecture is an end, and architecture is a process, and it continues forever. And so to future-proof, you have to think about change, and I think that's one of the key elements that we lack. You know, the data warehouse methodology, for example, for BI is all about understanding the questions people ask right now to build a data model to hold that data so that they can ask those questions, which means that the moment something new comes along, it's not there, and you have to start over, you have to extend it. It doesn't incorporate change. And so I think step one is recognizing that change is what you're designing for. Change in data, change in use. And then from there, that starts to pull threads like on a sweater and unravel the sweater that is your current architecture. And so from there you go into another area, and you start thinking about how to put things together in maybe a different way or with different technologies.
So you're architecturing for change, actually.
Yes, you're designing and building so that you can accommodate different types of change. And the types of change that we're building for are not really today what we thought they were 20 years ago when we designed warehouse architectures in BI. We designed to make report changes or dashboard changes, or metric changes really quickly, and we do that very well. But when you're in an area where you don't know which data is important and which data you might need, that sort of change is slow change in our world. But that's the kind of rapid analytics change that's required. And so you need to think about how do we get data, collect data quickly? How do we make it available or index it? How do we analyze that data? And then if it's useful or reusable, how do you then take that data and turn it into something that becomes repeatable? It's just like you start out in a small town and you have a few roads, and then you begin to pave those roads, and eventually you widen some and you might knock down some buildings, but over time you are building up the repeatable patterns, and the things that are not repeatable that get thrown away, they get knocked down and cleared, and new things get added, and slowly a city grows. And if you do this well, you have a well-designed architecture that supports that, and at some point you'll always reach a time when you need to bring out the bulldozer and knock everything flat, start fresh. And I think we're in an era where that's becoming more common.
Okay, very clear. Your second session is on interpreting data and applying analytics. Is this some kind of learning path organizations need to go through? So do organizations need to become more data literate, or do you see that differently?
That's a good question. That talk is sort of 20 years of my career history, doing the same thing over and over again, and what I find is that yes, there is a maturity with organizations. It's just like with BI. First, people questioned, what do you do with it? Is there any value in doing this? Why should we spend money building a data warehouse? And 20 years ago, that was trying to understand what you do with it. I think today, for the most part, everybody understands what you do with the data warehouse. I think the problem we have today with the BI environment is that people forgot all the things that it does that they don't think about anymore. Clean data is like clean water. Until you don't have clean data, you don't realize its value. So now we come along with new problems like two-axis problems, analytics problems, where it's not, here's a bar chart or here's a line chart, but here's a trade-off between two things. And it's a scatter plot, it's an area map, it's a mathematical relationship between 2 or 3 or 10 variables, and what do we do? That's an analytics problem. That's not SQL, that you don't model data for it the way you model for query, you don't use the same tools to do the analysis, and so you have to get to a basic understanding of the use of data before you can really get to a reasonable understanding of how to apply more advanced techniques. But that's not to say that companies that are bad at dashboards can't be good at analytics. I can point to plenty of examples because it's very narrow, focused, purpose kind of tools. So the other part of that is your suggestion of data literacy. I think it's not just data literacy. I think people just need to be decision literate. What kinds of goals do you have? How do you frame your goal in terms of something that you can achieve and measure? And then worry about whether it's an analytics problem or a math problem or a BI problem.
And what are the things that can help organizations to become more decision-oriented or to become more analytical?
I think that's where you get into two different areas. You know, one is on the BI department or the analysts or the people who have to work with numbers every day. And we've been focusing a lot of education effort lately on science and technology, engineering and math, the whole STEM curriculum in universities, which is exactly the wrong thing to do. I grew up in that environment. And then I spent the next 25 years learning about art and architecture and biology and all these other fields that aren't covered there. And the best data scientists I know have a background with some, mathematics. You have to have that education. But that is probably the easiest to learn part. The hard to learn part is curiosity and seeing patterns and making links where there isn't an obvious link. And that's for the practitioner. For an organization, it's this recognition that information is the embodied communications inside the business. And what you're really looking at as a manager isn't just these facts, because a lot of times it's your interpretation versus mine. And we argue about whose version is more correct. Does it work like this or does it work like that? And those stories, those explanations are not always buried in the numbers. They're in data that's not available. They're in other places. They require conversation, collaboration, debate. And so I think for that, getting away from an idea that the business is a machine or the organization is a machine. We went through the whole Mensch machine thing a long time ago, and that is a false model. It's a very mechanistic model. And the reality is that most things are nonlinear and have feedback loops and other problems. And when you try to reduce it to just the facts and make it a linear machine, that's when you make the terrible mistakes that put banks out of business and cost them billions of dollars. And that's the sort of thing where you have to be aware that it's more about the human communication and understanding and caring about seeing that explanation and understanding.
Okay, thanks for this interview, Mark.
Thank you.